सर
लिंक देंगे कि वहीं स्ट्रीमिंग पे?
मैं दे रहा हूँ सर, यूट्यूब से दे रहा हूँ, एक सेकंड दे।
नहीं नहीं, चैनल तो आपका है ही मेरे पास में, उस पे स्ट्रीमिंग का कुछ अभी दिखाया नहीं है सर।
दिखाएगा दिखाएगा सर, अभी स्टार्ट किए।
ठीक।
So hello my dear students, today we are going to continue our previous topic, which we are discussing the naming of aldehydes and ketones. We'll wait for few minutes until everyone is here. We'll wait for few more minutes until everyone is here, and then definitely we can continue. Just let me know if voice and everything is going fine. Then we can continue towards further topic today. In last class, what I remember that we are doing Kucherov's reaction for terminal and non-terminal alkenes. Just put a message in the chat box if things are going fine. Okay, just give a thumbs up in the chat box. So I think voice and everything going good. So now we should start today's topic. Number of students is very less, but okay, no problem. We can start today's topic, which is discussion regarding non-terminal alkynes. So non-terminal alkynes we discussed. Sir, I have R1, C triple bond C, R2. That means the alkyne is in the middle of two different carbon chain. Now that R1, R2 can be same or different depending upon symmetry. In this non-terminal alkyne, if you are treating HgSO4 and H2SO4, this reagent is our Kucherov's reaction reagent. So what will happen? What would be the product? Now first I will get R1 OH. The OH will add to the carbon having less number of hydrogen. Here neither has no hydrogen. So I told you one simple trick that you have to decide that the OH will go to that side where electron donating group is there. This group must be a electron donating group. Go back to GOC and find out which groups are electron donating group. Now here in the next step, which is reversible, we get the ketoenol tautomerism. R1 C double bond O CH2 R2. Agree? Very simple step is this one. Ketoenol tautomerism. After doing keto-enol tautomerism, you know keto form is generally more stable. Although there are cases where enol form is more stable, keto form is generally more stable. Now here you see, I have to ask you a reaction that is iodoform. Try reacting with I2NOH. You have studied iodoform reaction previously. What this base will do and how iodine will attach, just see and tell me what will happen if I treat iodoform here. Like if I treat I2NOH here, can I get iodoform reaction? Okay, next. Now, I asked you to read some oxidizing agents. So, what oxidizing agents are necessary to continue forward in this chapter? Let's go to the second slide and discuss the preparation of aldehydes and ketones from alcohols. Preparation of aldehyde and ketones from alcohols. Preparation from aldehyde and ketones from alcohols. So any doubts, just write the chart in the chat box. And yesterday or day before yesterday in class, whatever question I have given, just check once. Hopefully you have done. So if I treat PCC, what is PCC? Pyridinium chlorochromate. Pyridinium chlorochromate is a mild oxidizing agent or strong oxidizing agent? No, sir, mild oxidizing agent. Sir, this mild oxidizing agent should react with what? Now, should react with 1 degree alcohol to give us the respective aldehyde. So, you see the number of carbons here 1, 2, 3. So, what is the product I am getting? 1, 2, 3. Propanol. Very good. It's a mild oxidizing agent. Now, let's check what will happen if I treat PDC with a 2 degree alcohol. What would be the product formed? You have studied this in alcohol chapter. What is PDC? Pyridinium dichromate. Now you see, if I treat pyridinium dichromate, what I am obtaining as a product? Look, this is again 1 degree. So 1 degree will give us aldehyde again. But this is a branch chain aldehyde. Now further, let us go to the next slide and see what more reactions we can do. So now, one more reaction I should give to you people. I have a 3 degree, not a 3 degree alcohol, 3 degree substituent and then 1 degree group. Now I am treating, tell me what is the name of this reagent. I am treating CrO3 chromic oxide pyridine. You know what is pyridine? And DCM, dichloromethane, CH2Cl2 plus. So tell me, what is the name of this reagent? Do you remember? Is it a strong oxidizing agent or is it a mild oxidizing agent? Do you know what is the name of this reagent? Collins reagent. So this Collins reagent is also a mild oxidizing agent. So you know what is Collins reagent. Now what does this Collins reagent do? It will convert to the respective aldehyde. If it is a 1 degree alcohol, you will get the respective aldehyde. See, this is 1 carbon, 2 carbon and 3 carbon. So if I am going to name this aldehyde, first class we named in detail 1, 2, comma 2 dimethyl 2, comma 2 dimethyl propanol 2, comma 2 dimethyl propanol. Correct? So you got this as your product in Collins reagent reaction. Just go through it quickly. Now, let us proceed to the next slide and discuss about another similar mild oxidizing agent. Do you remember any other mild oxidizing agent? Then I will tell you about some specific oxidizing agent of this chapter and we go forward to the upcoming reactions. So now, if I am going to tell you regarding some mild oxidizing agents, So now let us go to the next slide and discuss regarding Sarret reagent. Sir, what is Sarret reagent? Sarret reagent is also an mild oxidizing agent. Sarret reagent is also a mild oxidizing agent. Now, this mild oxidizing agent has pyridine. Look, this is pyridine. We have CrO3, we have HCl, and we have CH2Cl2, DCM. Sir, how does it works? Now it converts 1 degree alcohol. Any mild oxidizing agent converts 1 degree alcohol to aldehyde and 2 degree alcohol to ketone. There won't be such change in the reaction if there is a 3 degree alcohol. So 1 degree alcohol is converted to aldehyde, whereas 2 degree alcohol is converted to ketone. Now, let us see about allylic or benzylic oxidation. What about allylic or benzylic oxidation? Now, there are reagents like MnO2 which prefer specifically allylic or benzylic oxidation, whereas the reagents like PCC or KMnO4 prefer different type of oxidation as they are mild and strong oxidizing agents respectively. So I'll give a reagent, I'll give a reactant and different reagents. You have to tell me what would be the product first. This is the reactant we have. 6-member cyclic ring. Double bond is there. OH is there. Another OH is there. You have three processes. First is you are treating with MnO2. MnO2 does allylic or benzylic, allylic or benzylic oxidation, whereas another reagent is PCC, pyridinium chlorochromate, is a mild oxidizing agent. And last but not the least is KMnO4 in acidic medium, which is a strong oxidizing agent. So, do you know what is the allylic group? sp2, sp2, sp3. This is your allylic carbon. Same in down, but down carbon does not have alcohol. So this allylic carbon has to be considered. If there is a OH group on this allylic carbon, that is called as allylic alcohol. So this is your first product. This is which is non-allylic. This non-allylic alcohol does not undergo any reaction. Whereas when you treat PCC, both of them undergo reaction. Here I get a aldehyde and up there I get a ketone. Whereas when we treat this strong oxidizing agent like KMnO4, down we convert it into a carboxylic acid. So strong oxidizing agent like KMnO4, K2Cr2O7H plus or KMnO4H plus or Jones reagent and Jones reagent What are the Jones reagent? CrO3, H plus, chromic acid and H plus. Sometimes we use H2CrO4 and H plus. All these are strong oxidizing agent. And we know any strong oxidizing agent converts 1 degree alcohol to respective carboxylic acid, whereas 2 degree alcohol, same as the previous case, converts to ketone. 2 degree alcohol to ketone and 1 degree alcohol to respective carboxylic acid. Is that clear? 1 degree alcohol will convert to respective carboxylic acid. So now let's go to the next slide and understand the next reagent. Hopefully you have done the copying and required thing. Let's go to the next slide and check the next part of the topic. Okay, so now I will tell you about copper 300 degrees centigrade or copper 573 Kelvin. Now, what is the use of this copper? This will act as a oxidizing agent, but like mild. Mild obviously converts the 1 degree alcohol at copper heat or copper 300. We get as respective aldehyde RC double bond OH. Along with that, I get H2 gas. Here we see RCHOH. Along with copper heat, I get RC double bond OR, which is a ketone, which is a aldehyde, along with loss of hydrogen. See, now this last one is a triple star reaction from your NCERT textbook only, nothing very new, you know. But sometimes we forget, even after knowing everything, we do mistakes. So, what is the mistake we are doing even after knowing this reaction? So, here you see, when I have a tertiary alcohol and I treat with copper 300, what will happen? Now, here we don't get the respective oxidation. Rather than that, we get the formation of double bond or unsaturation. So, this happens as a elimination reaction. Now, this elimination is not an oxidation reaction, so is a different type of reaction occurring here when I'm treating copper 300 with this case. Yeah, is it audible, my dear students? Hopefully, it is audible. I am talking at my maximum voice. Hopefully, this is working and audible. Just let me know. Sahin Sultana, is it audible? Please just let me know. Now we Please let me know if it is clearly audible. If my voice is clearly audible, my dear students. Give me a minute. Let me check if there is any improvement I can do. Just give me a minute. Is it okay? Just give me a second. Yeah. Now I think things voice will be just also. Just tell me if the voice is good to go. Please know the last reaction. I have a question for you, very small question here. I have a very small question for you. See this one. If I have cyclohexanol, in this cyclohexanol, if I am check if it is still unclear. Yeah, check if the voice is still unclear. We will definitely see. Let me check myself. See this one. If I think it's clear, my dear students. I have checked in my device. It's clear. Just check about network once. Now, see, in this one, again you are treating copper 300 degrees centigrade. What will happen? Tell me the degree of this alcohol. Yes, sir, that is a 2-degree alcohol. So 2-degree alcohol will convert to respective ketone. We get the respective ketone when we treat with a 2-degree alcohol. Now, let's see how we can convert to respective aldehyde from how we can get the respective aldehyde from acid chloride. Sir, what is that acid chloride and how to get the respective aldehyde or ketones from acid chloride? We cannot get ketones, but we can get aldehyde from, yeah, thank you, it's clear. So it's clear for everyone, whoever are attending the classes. Very good. So from acid chloride, here I have a name reaction for all of you. That is Rosenmund's reduction. That is Rosenmund's reduction. Sir, what do you mean by Rosenmund reduction? Here you have to know the reagent of this reaction along with solvent. The reagent is, yeah, the reagent is H2PdBaSO4. The reagent is H2PdBaSO4. Regarding BaSO4, it is a catalytic poison, which means it stops the oxidation at aldehyde phase. Whereas the solvent used in this reaction, yeah, very good. H2PdBaSO4 is Rosenmund's catalyst. We used it somewhere else. You have to remember where we use Lindlar catalyst and Rosenmund catalyst when we are converting triple bond to which type of alkene, cis alkene or trans alkene. You have to revise and tell me from alkene chapter. Yeah, very good, very good. So now, what else is there in this reaction? I have a solvent called boiling xylene. Boiling xylene is my solvent. Now what we will do? Now we'll start the reaction. I have RC double bond OCl. And while treating this in presence of H2PdBaSO4 and boiling xylene, the acid chloride converts, yeah, very good. The acid chloride converts to respective aldehyde. So it is a good method to prepare aldehyde from acid chloride. Sir, example, yeah, we can start with a simple example. You see, I have benzoyl chloride. Copy the reagent on benzoyl chloride and tell me what would be the product. If you copy the reagent on benzoyl chloride, what would be the product? Which aldehyde will form? Aromatic aldehyde or aliphatic aldehyde? Is this aldehyde that much important? Yes, sir. The name of the aldehyde is benzaldehyde. From benzoyl chloride, I make benzaldehyde. From benzoyl chloride, we make benzaldehyde. Now, as I reminded you the other reaction, which one? Ozone-lysis already I told you yesterday. What was the other reaction? Any unsymmetrical alkyne to cis alkene H2PdBaSO4, Rosenmund as well as Lindlar. H2PdBaSO4 is done by Rosenmund as well as Lindlar. Let's go to the next slide. Important name reaction, Rosenmund is covered. Now, what is the other reaction of the same reagent which we have already studied? Any alkyne you have, C triple bond C R2. Any alkyne you have can react with similar reagent H2PDC, H2PdBaSO4 or H2PdCaCO3. Now, this reagent is useful to make cis alkene, and both the hydrogens, I'll show you the mechanism. It will be a surface mechanism, spaceship mechanism also we call it. Both the hydrogens add up on same side and we get both the R value R1, R2 on the similar side. Now, what we got? We got a cis alkene, formation of cis alkene. Alkyne undergoes selective reduction. So, alkyne undergoes selective reduction. This is Lindlar. Above one, you know, Rosenmund. So, both Lindlar and Rosenmund help us in this reaction. One more thing you have to be careful. This acid chloride can react with LiAlH4. Do you remember what was the product if I treat this with LiAlH4, NaBH4 or H2PD? Do you remember what was the product in all three cases? R CH2OH. That is a 1 degree alcohol. Any of the reducing agent gives us 1 degree alcohol. That is complete reduction. And yeah, cis, very good, very good. So that is complete reduction. This complete reduction gives us 1 degree alcohol. Whereas if I treat BH3THF or B2H6THF, BH3THF or B2H6THF. Do you know what would be the product if acid chloride reacts with hydroboration reduction? This is hydroboration reduction, HBr. Not hydroboration oxidation, hydroboration reduction. Acid chloride reacts for hydroboration reduction reaction, what would be the product? Can you guess? Anyone? Can anyone give me the product for this hydroboration reduction reaction? Today we'll complete all the preparation methods. Few more methods are there. Dival H is there. Etard reaction, very important. Stephens reduction is there. Mechanism of Stephens. Etard reaction, if you want mechanism. Then along with that we have Gatterman aldehyde synthesis. So lot of reactions are there. Hopefully we complete all the preparation methods today and go to the upcoming slides. Done. So next, from cyanides. So if you have R, C, triple bond, N. Previous page I didn't tell you what will happen. This one, no reaction. This one, no reaction. So next, here you see what I have. I have SnCl2, HCl, H3O plus. Same I have SnHCl. Now what would be the product? RCH double bond NH. This product is a imine, formation of imine. Now next one, what would be the next product after this? Now here I will react with water molecule, addition of water molecule. So what will happen if 1 mole of water molecule is added? Now we would be getting R CHOH and we will be getting NH2. Now removal of a water molecule in a correct way releases ammonia upon heating and we get the respective aldehyde. We get respective aldehyde. This is also known as Stephens reduction. Whereas if you treat with only SnHCl, you directly get amine. So what is the mechanism? Let's start the mechanism in this slide. Let's start the mechanism in this slide. Yeah, when do we start carboxylic acid? My dear students, aldehyde ketone is the biggest part. Carboxylic acid has lesser part compared to this aldehyde ketone. The amount of weightage carboxylic acid has is less. So first we have to complete aldehyde and ketone properly. In our mains, advanced or NEET exams, we have higher weightage from aldehyde ketone. Especially in your advanced exam, you get a lot of mechanisms for here from here. Then acid also has not have zero weightage but less compared to this. So here you see what you obtain. Now Sn plus 2 electrons along with Cl2 gas. This is the first step of the mechanism and Cl2 gas is evolved. Now you see those two electron which is evolved from here is added across the C triple bond C and I get C minus double bond N minus. Now this starting material gains 2H plus from the acidic medium which is HCl and what I get CH double bond NH is imine, formation of imine. So see first two steps of the Stephen's reduction or Stephen reaction, first two steps are very, very simple. So let me drink a little bit of water. Third step is you can go for partial hydrolysis and heating. You can go for complete hydrolysis also. So let's see, we'll do complete hydrolysis of imine. Third step of the mechanism, complete hydrolysis. Complete hydrolysis of imines. Sir, let us draw imine correctly. R CH double bond NH. This is del negative. This is del positive. Break the bond. You have OH minus on this side, OH minus on this side. So negative part of the addendum goes to the carbon having del positive. Here you see, after hydrolysis, ammonia gas is evolved. Along with that, I have 2 OH on same carbon. So gem diol 2 OH on the same carbon is unstable. So you have to remove one water molecule to make it a stable compound. C double bond O and H. So you get formation of aldehyde. So I'll give you a simple question here and then we go to the next part. Dibyl H. We'll go to the next reagent, that is dibyl H. I'll give you a very simple reaction here, one or two simple reactions to solve, and then we go to dibyl H. So I'll give you a very simple reaction to continue, and then we'll go to dibyl H. So let's go to the next slide and see what we can do with few questions on this. So first question on this particular reaction. See, I have a starting material 4 carbon chloride. I am treating NaCN. We obtain A. This A reacts with both the reagents I am telling you. One is SnHCl. Stephen's reaction has two reagents and SnCl2HCl in presence of hydrolysis. What you got? Now here you got B, here you got C. This C is further reacted with Grignard CH3 MgBr and gives us the product D, followed by Grignard followed by hydrolysis. So this is the first question all of you has to attempt. I know you know about Grignard's reagent. Now next question, simpler one, relatively simpler one for all of you, that is treating H2PD BaSO4. Treating H2PD BaSO4. See what you will get as your A. After getting that A, I am treating Li, Al D4 and giving B. Think, answer. Think a lot. Try to answer. Give the IUPAC name of the answers in the comment box. Comment the IUPAC names of the answer. For example, question 2, what is A? What is B? In question 1, what is A, B, C, D? You can easily predict it. Simple. Just try both the questions. So quickly solve up to this. We'll start dival H onwards tomorrow. More new reactions will be there. So just listen carefully. We will start from dival H onwards tomorrow. We'll complete all the other preparation methods of aldehydes and ketones. If you want me to tell preparation of acids, now I will start the preparation of acids also. Okay. And once we are done with all the preparations and all, then we will go to physical properties and chemical reaction. Have patience. This chapter is a lengthy chapter. This is not a chapter which completes within 10-12 pages. It takes a lot of patience, lot of practice. And if you are really preparing up to advanced level, you have to prepare really well. And if you target a higher score in NEET chemistry also, you have to know all the varieties, all the cases of this chapter. Okay, so I'll try to cover all the maximum models possible anywhere, whatever questions you get could be covered in your classwork. Just you have to have patience and listen. Okay, thank you. Today we'll wind up here and see you in the next class, all of you.